Hello, here's question 1.1.23. It says to find a and b given that these three terms are in arithmetic and then these three terms rearranged are in a geometric, which is a pretty cool question. But the first thing you need to realize is that there are long ways to do this problem and there's also very short ways to do this problem. I want to remind you of something before we start. Let's say we have an arithmetic progression where we start with 6, 9, and we add 3, we get 12. So I just want you to remember that the vocabulary in arithmetic and geometric is, arithmetic, we have a common difference. It means 12 minus 9 is 3. 9 minus 6 is 3. And that will always happen with the arithmetic. So if we use that, that should help us with this problem. So we should have b minus 1 will be the same thing as 1 minus a. And similarly, with the geometric, we can go b divide a is the same thing as a divide 1. So those should be our two equations, and we have two unknowns, so all we need is two equations. So if I cross multiply here, we get a squared is equal to 1. And if I substitute a squared, I get is equal to b. So if I substitute in, we should have a squared minus 1 is equal to 1 minus a. Do some rearranging. We have a squared plus a minus 2 equals 0. And we should be able to factor this. A, 2, 1, plus and minus. So we should have a equals negative 2, and also a is equal to 1. And now we can go back and find out what b was. If a squared is equal to b, so that means b will either be 4 or b will be 1. And it says a is not equal to b, so we can cancel this one out because those would have been the same. So let's make sure that this is actually in the progression. It says a1b, so a, negative 2, b, 1, and then b is 4. So that goes up by 3 and up by 3. That looks like an arithmetic. And then the geometric, we have 1, a, negative 2, and b, which is 4. So then multiply by negative 2 and multiply by negative 2 again. So yes, that does work.